Okay.
And line doesn't.
Okay. So if I say any other difference? See, the difference between a line segment and a line is this. Okay, you said a line doesn't have points. A line segment has points. If I say that this is A and this point is B, can I say that?
Yeah.
Right, I can say that, right? So see, that the only difference between line segment and line, actually not the only difference, there are many differences. So the difference, the main point of difference is that a line segment is a part of a line. Okay. Did you understand?
Can you explain it?
Yeah, wait, I'm trying to make a perfect line segment. There you go. See, segment in English language means part. What does segment mean? It means part. Like for example, you say that I am dividing something into many segments. Okay, so segment means a part. So a line segment is a part of a line. What does that mean? See, a line is infinite. Okay, it is infinite. It has no starting or ending point. It has no starting point and no ending point. Okay, but a line segment, as you can see from here, this line segment, the pink thing, this is the starting point of the line segment. Let's call it A, and the ending point, let's call it B. Okay, so let's say you have a line and you mark a particular part of it, you mark a portion of it. Okay, or let's say you paint a small portion of it. That is your line segment, and the rest of the whole line, which is going on infinitely, that is called a line, and this a small part of it is a line segment. Okay,
so
a line segment. Yes.
So the points A, B are called part, like segment, and the rest of it is called line.
No, the point A, B are not called segment. The points A and B are the starting and ending point of a line segment. So this whole pink thing that you can see here, if you can see carefully, that is the line segment. A and B are just points. A, B, and you denote it like this. This is your line segment. Okay. And if you're talking about the line, then how do we identify a line? We identify a line by, because see, a line does not have a starting and ending point. So how will we identify it? We will say that, okay, I have a particular line and it is passing through 2 points, let's say M and N. Then I will call this line as MN, and on top of that I will put this these 2 arrows. Okay, that's how we denote a line. So over here, we will call this line as line AB. Okay, how will you read it out? You will read it out as line AB. Okay, and this is your line segment AB. Notice the difference between how we are writing them. Fine?
Okay, what is a segment?
Sorry?
What is the segment in line segment?
Hiba, I'll just be right back in 1 minute. There's an insect over here. Okay, just a minute. Yeah, Hiba, I'm sorry about that. Can you continue? Okay, so you have typed it in the chat box. What is a segment in line segment? Uh, see, if I say line segment, if I say line segment, I mean this. Okay, you can measure it. You can take your scale, your ruler, and you can measure it from here to here. Okay, you're asking what does the segment mean? See, when I say line segment, what I mean is it is a part of a line, part of a line. Okay, because segment means part. Um, yeah. So let's say you have a triangle. Can you see this triangle, Hiba?
Yes.
This triangle, now I will ask you a question. You have two options. This triangle has, now you have two options. You have to choose the correct option. A, 3 lines, or B, 3 line segments. Choose your answer carefully. Hmm.
3 lines.
Okay. Are these lines, do they have arrows? No, they don't have arrows. Are they going on indefinitely, or can you take a scale can you take a scale to measure these sides of the triangle? Can you take a scale and measure the sides of the triangle? Can you measure it? Let's say if I say this is equal to 3 centimeters, and this is equal to 2 centimeters, and this is equal to, let's say again, 3 centimeters. So you're able to measure it, right? But a line is infinite. A line goes on till infinity. That is the thing about a line. The reason being it has these arrows. That is how you recognize or identify a line. Are you understanding it now?
Yeah, but line segment also has like arrows.
No, line segment doesn't have arrows. Where can you see arrows?
Oh, I was getting confused by the line.
Yeah, if you're getting confused, look at this one. No, look at this line segment. Fine. Can you see this? The one at the bottom? That is a line segment. Now, are you clear that this triangle is made up of 3 line segments and not 3 lines? Is that clear to you?
Yes.
Okay. Fine. So now the thing is, what we do is so here where 2 line segments are intersecting, we call this as a point, right? So because this is a point which is the starting point for both the line segments. It's the common point for both the line segments. Or you can say that these 2 line segments, the blue one and the orange one, they are intersecting at this point A. Then the orange line segment and the brown line segment are intersecting at the point B, and the brown and blue line segments are intersecting at the point C. So that is why we call this triangle, and this is how we label it, or this is a symbol for triangle. Okay, triangle ABC. Okay, Hiba, shall we move on?
Yes.
All right. Now, one more thing that if you might remember. Okay, what is an angle, Hiba? Do you remember what's an angle?
Yeah, like 90-degree angle and 180-degree angle.
Okay. Can you define an angle? Or can you tell me how many angles can you see on this whiteboard? Like if you were to say like the whole whiteboard. Wait. So this whole whiteboard, how many angles are there? Or let me ask you like this. So okay, what shape is the whiteboard?
Square.
It's actually more of a rectangle, right?
Or, yeah.
Okay. So let's say this is the shape of the whiteboard. How many angles does it have?
4.
Very good. It has 4 angles. So that is what I was asking you. How many angles are there in your whiteboard? And what is the measure of each of these angles?
1.
No. How much? What is the measure of each of these angles? What angle is this?
2.
No. What is? How many degrees is this angle?
This is like one line.
This is 90 degrees, right? This is a right angle, isn't it?
Yeah.
This is a right angle. And so is this. This is also a right angle. All of these angles are right angles. Okay. All right. So this is about fine. So how we can define angles is okay. Wait. How we can define angles is when you have, now hear carefully, when you have three or not three, sorry, when two lines or two line segments meet or intersect. Meet and intersect is the same thing. When two lines or two line segments meet, it's they form an angle, right? So you can you see these two line segments. Now let me name them. This is a line segment AB. Why is this a line segment AB? Because it is connecting the 2 points A and B. Can you see this orange line segment AB?
Yes.
Yeah. So this is the line segment AB. Now look at this and the line segment BC. Oops, sorry. The line segment BC. Can you see the yellow line segment BC? Wait, I haven't named C. How would you know? Just a minute. So this is C. Can you see C over here?
Yes.
Okay. So can you see that two line segments are meeting? At what point are they meeting, Hiba? Which is the point at which orange
A,
and yellow line segments are meeting? What?
BC.
No, they are meeting at one point only. That point is point B. Where are they meeting, Hiba? Can you see? Are you able to understand?
B.
Yes, they are meeting at point B. So you can see that when they are meeting, they are making an angle, right? And this angle happens to be 90 degrees if you measure it.
There
Now,
is no point at C.
oh, there is a point. C is a point, right? I just haven't marked it. But it's a point only. Fine. See,
Yes.
I'll tell you the difference. This is a point. This is not a point. We just write it like this so that we can make it more clear. But this is actually not a point. It's a circle. A point is something that is so small that you cannot divide it any further. Are you understanding?
Yes.
Fine. Acha, Hiba, just one more thing I'd like to ask you before we move further. Wait. Yeah, tell me this. Let me just write it down. That will be better. Can you see this?
Yeah.
Yeah. So can you tell me, can two lines intersect in more than one point? Like, for example, let me show you how lines intersect. Okay. So let's say this is one line and this is another line. And the point at which they are intersecting, let's call it point O. Okay. Now, can you look at this question and tell me, can they intersect? Can two lines intersect in more than one point?
Yeah.
Yes. Can you show me how? Please draw it in your notebook if you think it is possible. And show me how they are intersecting. What does it look like?
Can I take any alphabet?
Yeah, of course, you can take any alphabet at all.
No, they can't intersect because there's a point. The point O is in the middle, and if we try to connect them, it's going to like pass.
Yes,
I mean, it's
you
going to
cannot.
connect with point
Hmm.
O, so we can't do
Hmm.
that.
Exactly. Very good, Eva. Okay, let me give you one more example of two lines intersecting. See, like if you have this line going from here to here. Okay. You have another line going from here to here. Matlab, it's not from here to here. Matlab, it is obviously more, or you can say it is infinite, right? It doesn't, this line doesn't just end here. It doesn't just end here. No, it goes on till infinity. You can keep on extending it, and it will go on till infinity. It will go on beyond the screen. It will go on beyond the room, beyond, like it will, this line is basically infinite. So that's why we draw the arrows to show that it extends forever. So now these two are intersecting at this point, which is, we can name it anything, A, B, C, whatever. Okay, fine. Now one more question for you. Can you see the question? Can more than two lines intersect in one point?
They can intersect.
Sorry, can you repeat?
They cannot intersect.
Can more than two lines intersect in one point? You're saying they cannot? Okay, let me show you. Let me show you. Let me first just erase this. So we have this one point O. I'm just not writing it because of convenience sake. Let me show you one more point that will go to, that will intersect through this point. One more line, sorry. How many lines are intersecting in this point? Hiba,
He,
3. Can I add one more and make it 4? Can I add one more and make it 5?
yes.
And can I add one more and make it 6 lines?
Yes.
How many lines can I go on like this? How many lines do you think? Let me show you. Okay,
Like
let me
how?
show you. You think till then I'll open this website and I'll show you. How many lines do you think can pass through the same point?
10.
Why not 11? Yeah, why not 11?
Also.
11 can also pass. Then how many? Why only like 11? Then what about 50? What about 100?
Like infinity.
Yeah, very good. Infinity. So I'm going to share. Wait. You can see this now. So I'm going to
Yeah.
mark a point somewhere. Let's say this point, or let's say this point. Okay. Now I am going to make, well, I need the line. Construct the line. Yeah, okay. Great. 2 points of positions. Fine. So I have, let's say this. Fine. I have this line that's passing through it. Then wait. Where did it go? There it is. Okay. Then I have this line passing through it. Then I have, so that's 2 lines, 3 lines. Keep counting, okay? 4 lines, 5 lines. Oh no, wait, this one is somewhat
4. No,
messed up. Wait, 1, 1, 1, 2, 2 and 3. So 2 and 3. Okay. Oh no, bro. 1 second. Delete. And this point also. This point. Okay, Hiba. Can you see how many lines are passing through that point, that one point, which is A, right? Then you can keep on having lines, and at the point when you think, oh, my screen is full of lines, the whole thing might turn black, right? You keep on adding, the whole thing will turn black, but you can always just keep zooming in and keep adding more and more and more lines. See, I'm still able to add lines, even though it looks so congested, but I can still add more and more lines, right?
Can you show how?
Okay, let me just zoom it in. Okay, so this is all very, you can say, Gerber types. Actually, I made it very roughly because I was trying to make it fast. That's why it wasn't very accurate. But can you see that I'm still able to add new lines?
Yes.
Even though the thing became very crowded, I'm still able to add more lines. And over here also, you can add multiple lines. So how many are there? I think it's been more than 30 now. Actually, no, I think it's been more than 20 now. So now it looks very crowded now. It looks like, okay, we don't even have any space left. But if you zoom in, okay, wait. Can you see that we still have space?
Yes.
Now, somehow magically, a lot of space has emerged, hasn't it?
Yes.
So again, now you can add more lines over here. See? Are you understanding how this is working?
Yes.
So you can keep on adding. till infinity, and you can keep on zooming till infinity, and you will never run out of space to add more and more lines intersecting through this point. Okay, now let's zoom out and see how it's looking from the point where we started. So those lines, they went way off the right point actually, because we were doing it so roughly.
Yeah.
See, this is from where we started. They're also crowded, no? And it all looks so messed up. But so the point over here is that the more you zoom in, the more space you will get. Okay, fine. So let's come back to our. By the way, you can use this website for experimenting with stuff. Just play around with the stuff whenever you're free. This is called geogebra.org. Okay.
Yeah.
All right. So now, what is the answer for the second question? Can more than two lines intersect in one point?
Yes.
Yes. Now, another question I have for you. What about if you have, or let's say we have 2 points. Okay. Can more than one line in, no, not intersect. Can more than one line pass through two given points? Given points means these two are fixed points. You can't move them. Can more than one line pass through these 2 points? Let's say this point is A and this is B. So first let's try to create a line that passes through these 2 points. So this is the way. Wait. Okay. So this line is passing through these 2 points. Can more than one line, so you can see this red line. Can any line other than this red line pass through these 2 points? Are you getting the question, Hiba?
Yes.
Yeah?
Yes. But they can't can't add more.
Yeah, Hiba, your voice is like you're very
We
you're not
cannot add
audible very
more
clear.
than one line.
Yeah, you cannot have more than one line passing through two given points, because if you try to make it pass through these 2 points, it just can't, right? Because it will go like this, or it will go like that. Then it will only be passing. Let's say if you have a line which passes through A, then it will only pass through A. It won't be able to pass through B. So there will be only one unique line, only one line that passes through two given points. Is that clear?
Yes.
Okay. Um, let's move forward. Okay. Now let's just recall what are the types of angles. Do you remember?
Yeah. Straight angle.
Okay. So now see the types of angles, we classify them based on measure. Wait. Actually, no. Sorry. Yeah. Continue. So you said straight angle. Straight angle is what?
180 degree.
Very good. Straight angle is 180 degrees. Then
Wait a minute. A right angle.
right angle is
90 degree.
90 degrees. Then
Like acute angle.
very good. Acute angle is
is less than 90 degrees.
Very good. So acute angle is less than 90 degrees.
And it was like obtuse.
Obtuse. Very good. Very good. Obtuse angle, that is?
It is more than 90 degree, but it is less than 180 degree.
Very good. So it is more than 90 degrees, but less than 180 degrees. Okay. All right. Or you can say it lies between 90 to 180 degrees. Then what if something is more than 180 degrees? What do we call it?
360.
Reflex angle.
Oh, yeah, reflex.
Reflex angle is
360.
greater than 180 degrees. Not necessarily 360. It can be 200 degrees. It can be 250 to 70 degrees. Okay. And when something is 360 degrees, it is called a zero angle. Zero angle means it is, you can call it 0 degrees or you can call it 360 degrees because it looks the same. Okay. Like if you have these two rays, then that's the zero angle. Okay. Fine. Okay. Now let's talk about this thing called complementary angles. Okay. I'll tell you before writing it down, I'll just tell you what it means. So you can see let's see a right angle. Okay. Let's see a right angle. So you have this and you have this. This is a right angle. Somewhat, it looks like a right angle only. Fine. Now, let's say you have two, it's made up of two angles. This right angle is made up of two angles such that, oh wait, okay, it is, this one is like this and the other angle is like this. Okay, so you can say, fine. Okay, are you able to see the two angles now or should I draw them for you? So
Yeah, I can
this,
see it.
let's say this is 30 degrees and this one is your 60 degrees. Okay, so these two angles which when combined, or you can say which when added give you 90 degrees, these are called complementary angles. Complementary angles. Okay, so if I say what is the complementary angle of 30 degrees, what will your answer be?
Sorry, 60.
60 degrees. Yes.
Okay, can you tell me how?
Can I tell you? Can you repeat what are you asking?
Can you tell me how it is 60?
Because what is 60 plus 30?
And 90.
90. So complementary angles are those angles which when you add them, it gives you 90 degrees or it gives you a right angle. Is it clear now?
Yes.
Okay, good. So this is about complementary angles. The next thing is very similar to this. It's so if you have a straight angle, let me just draw a straight angle. Wait, yeah. So this is your straight angle. Or wait a minute. This is your straight angle. And let's say you have two angles on it. Let's say you have two angles. Let's say this one. Oh God. Yeah. Let's say you have this and this. Okay. And then you have another angle which is from here till 6. I'm sorry about that. I was just trying to make it a little accurate. Okay, so are you able to see these two angles now?
Yes.
So let's say this is 120 degrees and this one is 60 degrees. Okay, what is 120 plus 60? Yeah,
180.
180 degrees. And 180 degrees is a straight angle, right?
Yeah.
Straight angle. So these two angles will be called supplementary angles. Now what happens, Hiba, is that many a times students get confused between students get confused between these two things, which is complementary angles and supplementary angles. Sometimes they get confused that, okay, do supplementary angles add up to 90 or do complementary angles add up to 90? Okay, so they get confused in that. So there's a trick to remember this, and that is, see, you can see the S over here, S for straight and S for supplementary. Fine. Is that okay?
Yeah.
Okay. Hiba, just give me 1 minute, okay? 1 minute. Okay. So, yeah.
Can you explain what is complementary angle? I didn't understand.
Okay. Complementary angles are two angles which add up to 90 degrees. Okay. Complementary angles are two angles which add up to 90 degrees. Or you can think about it like this, in case you forget. So you can write it like, okay, this is a 90 degree, fine, complementary angle. And supplementary angle, it's two angles which when you add them give you a straight angle, 180 degrees. So what is the sum of two complementary angles? Yes, Hiba?
120 and 60.
No. Sum of complementary angles is 90 degrees. Okay, complementary angles, I'm just giving you an example. This is just an example of 30 and 60. Complementary angles are those which when added give you 90 degrees. I'll give you another example. 45 and 45 degrees. Okay, let's say you have a right angle over here. Okay, and you have two angles over here, which are, one sec. So you have, this is your 45 degrees and this is another 45 degrees. So there are two angles, each 45 degrees. They are what? They are supplementary angles. Sorry, they are complementary angles. Why? Because their sum is 90 degrees. Their sum is 90 degrees. Similarly, you can have, let's say, 70 degrees and 20 degrees. You have two angles. One is 70, one is 20. So they are both complementary angles because their sum is 90. Is that clear?
Yes.
Okay. Okay, now there's a few questions. Open page number 95. Think, discuss, and write. Can you see that?
Okay. Yes.
Okay, so the first question in that, can two acute angles be complement to each other? That means complement to each other. That means you can say that be complementary to each other. Okay, they've just written it in a different way. Can two acute angles be complement to each other?
No.
No.
What does complementary means?
I just told you, right? Complementary angles are those angles whose sum is 90 degrees. Complementary angles are those angles whose sum is 90 degrees.
So if this can two acute angles be complement to each other, can we take the angles as any number but
Yes.
less than 90?
Yeah, they're asking you whether two acute angles, is it possible for two acute angles to be complementary to each other?
Yes, they can.
Yes, they can. In fact, two acute angles only will be, right?
Yeah.
Okay, fine. So take a look at question number 2. Can two obtuse angles be complement to each other?
No.
No, obviously not, because obtuse angles are already greater than 90. Right? Let's say this is one angle. This is already greater than 90. If you add something else to it, it will be greater than 90, right? But your 90 degrees is supposed to be over here. So it will never fit into the 90 degrees. Are you understanding?
Yes.
So then the third one, can two right angles be complement to each other?
No.
No. Fine. So only the first one will be right, that if you want two complementary angles, then both of them will always be acute angles. Okay. Fine. Okay. Now let's see page number, what is that? 96. Page 96.
Yes.
Think, think, discuss, and write. Can two obtuse angles be supplementary? Two obtuse angles. Take a look at this. Okay. Yeah.
Yes.
Two obtuse angles can be supplementary. Okay. Let's say one obtuse angle is what's greater than 90? 100. And the other is also greater than 90. It is, let's say, 110. When you add them, they are going to be 210, and that's more than 180. But you want it to be equal to 180, right? Because supplementary angles means their sum should be equal to 180. So if something has to be equal to 180, see, if something has to be equal to 180, either it will be two right angles, 90 plus 90, or if one angle is obtuse, then the other should be acute, right? Otherwise, if the other one is also, if the second angle is also obtuse, or if the second angle is 90 plus, it's greater than 90, then it won't be equal to 180. In fact, it will be greater than 180. Are you understanding this, Hiba? Hiba?
Yes, the answer will be no. They can't
No.
supplement
Can
with each other.
two acute angles be supplementary?
Yes.
Yes, two acute angles can be supplementary. Are you sure about that? See, if you have two angles, which both of them are less than 90. Okay, let me just draw this for you. Okay.
No, they can. No,
No, they cannot. Very good. And why?
because we have to get a number which is more than 90 to make it
Yes.
supplementary.
Yes. So one angle should be more than 90, one angle should be less than 90, or both of them should be 90-90, right? So, okay. So I don't have to draw this. Can two right angles be supplementary? Hiba, question number 3.
No,
No. What is the measure of two right angles?
90 degree. Exact.
90 plus 90, right? So
Oh,
when
yeah,
you
it
add
is
them,
80, 180, so it will be supplementary.
yes, two right angles can be supplementary. Okay. Now let's take a look at fine. So Hiba, let's say you have a rectangle over here. Okay. This is one angle and this is one angle. Now I'm giving you a few more examples. You have a triangle. You have 3 angles over here. Actually, I didn't draw all the 4 angles of the rectangle because I didn't need to. So let's say I'm just going to draw 2 angles. Okay, this and this. If you notice, wait. So this is one angle. Okay. And the other one is this one. Yeah. Now you can see the 2 angles separately. Are you able to see them separately?
Yes.
Yeah. And similarly, you can imagine the same for the rectangle as well. Now you have 2 more angles I'm going to give you. Let's say this angle, and you have one more, this angle. Okay. So I'm going to give you, this is one pair of angles. This is one pair of angles. Just a sec. This is one pair of angles, and I'm going to give you one more pair. You have this, and this. Okay, this is not 90 degrees necessarily. It could be anything. Fine. And I'm going to make them a little bit colorful so that you can easily see the difference between all of these. Oh, sorry. It's supposed to be. Okay. So Hiba, you can see this is one angle and this is one angle. Now, so there's one thing, a term that we have, which is called adjacent angles. Okay. Adjacent angles means angles that have that share a common vertex. Okay, angles that share a common vertex and a common arm. Or let me give you one more example. Let me erase this. Okay. So you have this angle over here and this angle over here. Are you there, Hiba?
Yes.
Okay. So adjacent angles are angles which have a common arm and a common vertex. Okay. For example, take a look at the figure 5.8 on page number 97. You can see a book and a steering wheel, page number 97.
Yeah.
Yeah. So those, can you see on the book, they have like the pages of the book are making an angle with each other, right? So two pages like that, they're making an angle, and then the other two pages are making another angle B, and they share a common page. They share a common page. So angle A and B are called adjacent angles. And if you take a look at the steering wheel, these three angles, right, they are all adjacent angles to each other. Why? Because you can see that, let's talk about any two of those angles. They have a common arm and a common vertex. What do I mean by arm over here? Arm is this. This is called an arm of an angle, and this is called the vertex of an angle. Okay, the point where it is making the angle is called the vertex, and this is called the arm. So in the steering wheel, they are adjacent angles because they're sharing common vertex and common arm. Now, can you, I have to give you one more example. Wait. I know the time is up, just give me 2 moments. So let's say you have, no, this won't fit over here. Okay, fine. Let's say you have this, okay, and this, and this. Yeah. Hiba, you seeing?
Yes.
I'm making it really thick so that you can easily see it. Okay. So, Hiba, can you tell me, out of all of these figures that I have drawn, let me first name them, because without names, I think it will be difficult for you to point out which one you're talking about, right? So let me just give them all names.
Yeah.
This is angle A. This is actually, this is not the right way of naming angles. We will see them in the next class because it will take some time. So I don't want to start a new topic over here. This is angle C. This is angle D. This is angle E. Angle E. That's angle F. Okay. That's angle G and angle H. Angle I and angle J. Just a sec. Just take a look at all of them and tell me which one do you think, angle K and angle L. Out of these, which pairs of angles are adjacent angles? Look at the definition that I've written at the top left corner. Which of these are adjacent?
AB.
Very good. AB are adjacent because they have a common vertex, which is this, and a common arm, which is this.
Yes.
Okay, very good. And anything else?
I think GH.
GH.
No.
They are
No.
not, because they don't even have a common vertex and they don't even have a common arm. They don't have any common anything. Then what else?
So I think JI and VK.
JI. Okay, that's L. This is not V, it's L.
Oh, L.
Hiba, J and I. Do take a look at angle J. This, so this is angle J. This, my thing is going so slanting. This is angle J, fine. And this is angle I. They have a common arm, but do they have a common vertex?
No.
Are they having a common vertex? No. Common vertex means that this thing should be common. This thing should be common. The point where the angle is being made. So, and similarly, L and K also won't be adjacent. What else?
How is A and B like common vertex?
Common vertex. See this point? That's the vertex. Okay, see, for this angle, let's see for this angle. This is the vertex. For this angle, this is the vertex. For angle, this thing, for angle K, this is the vertex. At the point at which the angle is being made. So for angle AB, angle A and angle B, this is the vertex. Are you understanding?
Yes.
Okay, any other angles over here? Pairs of angles that are adjacent? No, that's it. Because over here, if you can see, they have common vertex, but no, this is the common vertex, but no common arm. Here also same, common vertex, no common arm. Over here, they have a common arm, but no common vertex, right? Okay.
Yeah.
Also, tell me one thing. Let me draw one last.
Can you tell me why JI doesn't have a common vertex?
Because what is the point at which angle J is being made? Angle J is made at this point. Angle I, what is the corner? Look at this corner. This is the corner, right? This is the corner where we are making this arc. So the corner or the vertex of I is this. Understanding? Can you see that there are two different vertices?
Yeah. And there's one at the top.
Yeah, that's not a vertex. That's a vertex of the triangle. That's not a vertex of the angle. Okay. So Hiba, let me just give you your homework. Please write it down. Fine. Your homework is open page number 95. Page 95. Try these. Okay, the whole box. Page 96. Try these. Try these. Page 96, the whole box. Okay, the box continues on the next page also. 96 and 97. Fine. So then, yeah, that's it. Also, page 98, think, discuss, and write. Think, discuss, and write. Okay, Eba?
Yes.